Okay, good evening guys, and thank you very much for coming. So I hope this presentation will be useful for you. Obviously, as with any mixed audience, it's very hard to, sometimes you get maybe too technical, less technical. I think our presentation tonight will hopefully cover the whole spectrum. So this one is a bit technical, but is not going into very deep technical aspects. And it's talking about overcoming the limits of machine learning in business. So with some people, when they see a title like this, they feel it's really very negative. And if I really don't believe in machine learning, I wouldn't be here, I wouldn't have a job. So it's really, I believe machine learning is one of the most creative and innovative and breakthrough technology business can use. However, with any technology, it has limits. If you don't understand it, you end up with burning your fingers or getting very bad results, getting bad repetition. And machine learning and AI in general have had this in the past because people love to get AI. The hype about AI is so high, so strong, that it gets almost every business really very keen to do AI. And if they do, and sometimes they rush into it, and sometimes they do it wrong. So here, this is the cautious sort of tale from the field. I spend most of my time, as Kim said, that as a consultant, and unfortunately, business use consultants to fix problems rather than to do the easiest stuff, which is very good. So giving exposure to many situations, businesses at different level of maturity and different number of technical debts. So I've seen the bad and how AI can fail. Currently, I'm a freelance AI architect, full stack data scientist, and I can explain that if people don't know what a full stack data scientist is, but shortly, it's really just looking at problems end to end, full stack, from the front end, back end, full solutions. And also I do data science training, and some of these aspects will become about how people learn data science. So what we're going to be talking about today, first I will give you a snapshot of current machine learning landscape to give you a feel. It could really, some of you, it could be really very old news, you have seen it all. Some you may be in a journey learning, some of it may be new. But I want to give you a snapshot, a simplified snapshot, what the current market is. And especially, again, following the hype, there's a number of techniques being overhyped, very high visibility, which is really mainly deep learning and reinforcement learning. And I will explain this briefly and say, do they change this landscape? Do they change these limits? Okay. Then I'll get into what are these limits. And to be practical, I want you not to just to give you what the problem is and what's the answer. So it's number of principles and guidelines how you would overcome these limits in business. So my discussion is focused on business rather than research. So it's not a research thing. So I assume like most of you coming from commercial organization, so that's really the focus on it. At the end, I will give a summary of what I've talked about and the conclusion and call for actions for you, how you take what you learned from this presentation to apply in your career, in your day-to-day job. So the first slide, it may be too busy, you may not be able to see everything. If you can see the main three groups, that will be suffice. And by the way, actually, I have a LinkedIn article with similar name, which has description of these things in more details, and I'll be updating it as well with some new information shortly. The main really thing you find about the landscape, it's so crowded. It's so crowded, no wonder actually many people trying to start data science learning and they get overwhelmed. This is a subset, this is not everything. and they get really overwhelmed at how much they have to learn. Okay, and we can very easily sort of group the things as a classical or legacy machine learning, and deep learning and reinforcement learning. This is a three group. Okay, within classical machine learning, these are supervised learning and unsupervised learning as a large two groups. Okay, and later on we'll look at some of the use cases of this. As I said, that's the main questions arise is that for somebody to say, do I need to learn all this? Well, how long it takes me? It may be 4 years. The course I'm teaching and I'm organizing is 3 months full time. It's still significant, but it really focuses on the practical aspects. And the question is that many of the courses, they teach all this, okay? And people actually have a lot of hard time going through all of them. However, now, what actually I want to tell you, like the summary to take of this, is some of these techniques are very, very old. They are 70, 80, maybe 100 years old from a statistical background, like linear regression, logistic regression. However, these are mainstays. They're still applicable now in business. Definitely, you'll not find a research scientist in university is studying logistic regression because it's well proven. And this actually would be my message here, is that these well proven techniques, they're here to stay, is not something you discard. Okay. However, because there's so many of these techniques, definitely the emerging deep learning replace some of this. And actually, in my curriculum, I'm removing some of these techniques because some of them get redundant. Okay. Reinforcement learning is emerging also as a very good replacement of some of these and as a complementary to them. So just very quickly, in case you don't know what a deep learning is, most of these techniques are based mathematically on statistical learning. Okay. And they tend to modify an equation, if you will, a polynomial equation. Most of them do that in a variety of different ways. Deep learning is using neural network, which is really sort of influenced by how the brain is structured, actually in a very, very simplified way. And they tend to use multi-layer, that's where it's deep, and that's actually, it allows them to do much more than any of these models, which really tend to be one-shot learning, okay, if you will. So these techniques are definitely extremely powerful, and they very applicable. Many people say other research techniques, but they are applicable to business. Reinforcement learning, the value it adds, it's separate. Most of these other techniques allow you to train a model on a data and then use it in a separate way. And if you want to modify it, you have to go back to the training. It's a very separate cycle. Reinforcement learning allows you to learn by experience, in a sense that you can learn and execute at the same time. That's a breakthrough, and that's actually probably the future of whole AI. Okay. So that's really the good news about these emerging techniques. Just for people who are learning, although actually it is a very crowded field, but as my students know, they really need to know only two libraries. If you do that in Python, it's two libraries here. Scikit-learn and Keras, with few lines of code, you do the things. So it's not rocket science, okay? But it still is very crowded and is evolving. So what we use these techniques for? So here, again, I'm focused on business. So this is the business use cases, and some of them already be maybe using them in your company, and they shouldn't really be, hopefully, very surprised. Again, the same unsupervised learning and supervised learning and unsupervised learning, and reinforcement learning, they are represented here. Somebody will ask, where is the deep learning? And here is the statement, that's something you take with you, is that deep learning can replace any of these powerful techniques above. All the classical ones here, you can use deep learning instead of them. However, I'll give you some cautious tale about that later. But in theory, that's just to give you a very quick positioning, okay? So you have supervised and unsupervised learning. You could use deep learning for majority of this. You could use reinforcement learning, which, as I said, it doesn't learn by training, it learns by experience. You can, some of these things, you can actually apply reinforcement learning. One example, I want just to give you an illustration. For example, text summary. So text summary, you could learn it by exposing the model to some article and some very exemplary summary and get them to learn from that. The problem with this is that as the summary is very likely to be a paragraph, and since the human will come up with a different paragraph, so immediately after the first or second word, the model will be completely wrong because it's deviated. It's talking about sequence. Where in reinforcement learning, what actually happened, the model generates a summary and a human vet it to say, does it make sense or no? And where is the error? So you can actually see that happening. Personalization is emerging as a very, very good technique for reinforcement learning. So what you do, you showing preference, showing suggestion to the customer. And if he shows the suggestion and it's not spot on, it's not a big deal, okay? But then you get the feedback from the customer and say, that doesn't make sense. So you take it and learn. So next recommendation would be better and better and better. Okay, without really sitting there and say, I want to learn everything about this customer before I'll be able to recommend to them. So it's really, as I said, it's a breakthrough in how we think about learning and training and executing machine learning. We'll allow you later on to have some questions, obviously. So I hope you remember these questions in the right place. So this is the limits. So that's the whole title of my presentation. So what are the limits? And this is the thing, some of you, if you're new to this, maybe some of them may not be very clear. But first, if you get just the point, there are limits, and you need to be aware of them. Are using this technology, if you use Segway versus a scooter versus a car, if you don't know the limits, and you take a car to drive on the pavement, I think you know it's wrong. You have to know what's the limit of the technology you're using. So here, the first one is a very fundamental, mathematical fundamental things, and I will illustrate it to you. It's a problem with induction. Machine learning learn from past experience. That's called induction versus deduction when you use syllogism and logic. And the problem with this is that because you learn only with what you've seen, you haven't seen something, you cannot predict it. And that's probably been made famous with the black swan effect. So if you train your model on white swans, it will never predict a black swan. And the first time it will see that, it will not believe it and will say something wrong. So the point is, well, humans have maybe some creativity. Sometimes they imagine things which doesn't exist, okay? Where machine learning will never categorically say no black swans. No free lunch is a similar thing. It's a mathematical theorem. As I just want you to may not digest it all, but you know these limits, which says that you cannot generalize machine learning. You cannot generalize machine learning model which works in one place to take it and you want it to perform the best in another problem. And this is really a problem now. Every time you learn anything, we build a model and we learn things from scratch. So these are fundamental problems. And later on we see that maybe there's no way to get around this because it's the mathematical constraints. However, problem with data, and it's really, if it's second focus of my talk is really on the data, is that people who get infatuated with machine learning or learning just naively first time, they love the model, they get data and they just apply the model, sometimes blindly, sometimes creating a blind spot. They just don't see what is the problem they want to solve. Should we solve this problem? If we solve it, how much we're going to gain? And they don't ask this question and end up with the sort of, as I said, wrong projects. So the problem with data, the number of them, just some of them about availability of labeled and reliable data. Because this is how machine learns, is that you have to have data labeled to say, this is a success. This customer have bought a home loan, this customer didn't. Okay, you have to have these labels, otherwise the machine will not learn. But it has to be reliable. If it has noise or has misleading information, collected wrong, have missing data, etc., it may not be very valuable for machine learning. But not only that, it's just like you don't need just one snapshot. You have to have a pipeline happening all the time. Noise and changeability of the data. So we had situation with customer who trained their customers on their for preference and campaigning, etc. But over the time, their demographics of their customer have changed, and the model started actually sort of deviating from what their current customers is. So you have to understand that this thing is, the machine just read it literally, and you have to be able to understand that moving window and how often you need to update your model. Bias in data, we heard that gender bias and racial bias, because the point is really, it is in the data. The model is not inventing anything. In the past, people hired more men than women for IT. So the model will say, when I see a man, I will say that's likely to be a candidate than a woman. It's not inventing anything, okay? And if you are not aware of this, so this is subtle information which we cannot see. If you live in a suburb with a postcode, maybe not in the bank's white list, okay, you will not get your loan, okay? Or you get very high insurance rate. And this is a model, just model seeing that in the past, it produced this result. So that's actually, to me, the data analysts, data scientists have to be aware of that and have to be sort of have their eye open for it and to overcome it when needed. Problem with the machine model itself, the machine model's ability to generalize. So as I said, we don't have, we have made great advances in machine learning, but we cannot generalize from one model to another. So every time we build models from scratch, and that's a very big limitation. We cannot transfer knowledge from one area to another. Brittleness is a very point I mentioned earlier, is that you could put a model in production, you test it with all your test data, it's giving you 90% accuracy, everything is hunky-dory, and then you put it in production, and it performed well for a while, and then it gives you a very brittle here, it means it gives you a very, very bad decision. Okay? It's not just like average decision, it's not sub-average, it gives you a catastrophic. And if your really business process built with that, it may be a straight-through processing, maybe that actually goes and you lose a customer or you damage things, you affect your compliance, etc. So this brittleness, it has to be really, we have to be aware of that. And in critical situation, you have to put a person in the middle or a man in the middle. Okay, you have to put checks and balances for that. You have to put rules. Okay, you have to understand what's the limitation of that model, because this model is doing what it has seen before, and you have to understand the parameters of that. Lack of interpretability is that, again, when you go to a bank and they refuse your loan, okay, loan application, you want a justification. You say, why? And actually, by law, okay, increasingly, there's a regulation demanding the organization to be able to justify a decision made by machine learning, by analytical models. And if you're using models which that doesn't show, cannot be interpreted, like the model cannot tell you why it's made this decision, it can be a very compliance issue. So having these limits, just very quickly to see, now we talk about deep learning as a silver bullet. Does it affect this? The good news, it affects some of them, it doesn't affect others. So the fundamental problems, they are not affected by deep learning because you follow the same mathematical ground truth. Problem with data, again, problem with data is actually sometimes deep learning exacerbates these problems because it requires much, much more data than this other model. It's more powerful, but requires more data. So you have to be aware of that. However, it's tend to be performing much better than other systems, so that's very good. Problem with the model itself, in research now, and actually I will explain how, like, if I say something in research, the business really sort of need to be aware of it, but should you really now, because it's a new research topic, you should start applying tomorrow. That I'll give you my comments on that in a while. So you have to, the problem with the models, some of them are elevated by the deep learning, but some of them stays, which is really makes the picture still, we have to be, even you apply deep learning, we think it's a really very powerful, still you have this limitations apply. So we have to tell you what to do about that. Okay, sorry, before that, deep learning itself, as I said, has some issues, and this is maybe more technical sort of content than the rest of the discussion. But just I want to really probably reason for including this is that deep learning is, as I said, the hype is so high about it that it will solve all problems. Actually, many people say, will give us general intelligence, and I think that's misguided. But some people, and that's some of these are vendors, pushing products. Some of them commentators want to just create excitement, etc. The main thing with deep learning, there are limitations currently at research and architecture, and which limits that. So just take this into the back of your mind, and when somebody tells you deep learning can do everything, so take that with a grain of salt and question it. That's really the point of this. Sorry, Hughes, if you're taking a picture. So getting into the practical one. So this is really very, it's not meant to be a panacea. It's just, it's guidelines, if you will. And really, it could be to management, but also to the technical person. I think the technical person is much more responsible because they understand the technicalities. Where somebody, a manager, a stakeholder, come and say, please use this, but I heard in the news AI can make us a lot of money, go and apply it and come tell me. And if you don't educate them to say, yes, machine learning works so well, but it has boundaries. And we need to understand these boundaries, have to work with these boundaries. So what actually are these limits and how you deal with it? Most important one, which is really people, once they see machine learning, they love it, they keep using it, and they forget about the data. They shape the data perhaps, but they don't understanding. So focus on the data and the domain knowledge is number one point which cause all the rest of the problem. Okay, if you want to rely on this machine learning to discover your word and model it for you, it's completely wrong. And so you really have to understand the data, use the modeling to help you with that. But the model by itself will not do that for you. And that's actually what I see, where is the fault? People get results, and they may get good results, but they have an idea, is this good result based on actual characteristics on my business, or is just accidental? In many cases, it could be accidental, and then you apply to other data, it gives you completely bizarre results. So understanding the domain of the data with the domain knowledge, using experts, conversation with experts is so important, number one. And it is really along the same line, is that understand the business context and say, should we solve this problem? You should ask this question. When you get a project, you ask this question, why should we do this project with machine learning? What are we going to gain? And get answer, okay? Next one, which I hinted about it before, is that follow the machine learning landscape, but deploy only N-1 technologies, okay? Don't be on the bleeding edge, okay? So what you do is that watch these technologies, they're doing these wonderful things, maybe experiment with it, but then use proven technologies only, okay? Because business is business. You don't want to really sort of haphazard things to happen. Use multiple algorithms. So all the things, as I said, really doing it in practice is not many line of code, there's simple packages to do it. But what you could do with just simple calls. You can apply deep learning, you can apply many algorithms. One of my ex-students applied 20 models in his last project. Good on you. It looked very good. After you deploy it, it's not the end of the story. You haven't finished yet. Okay? You have to monitor the performance. You can do reinforcement learning, but at least monitor it and understand, is it still performing well or not? Okay? And understand when do you have to take it back to the lab and do retraining. Next, qualifying problems for machine learning, and this is really just this again in the LinkedIn. There's an expansion of that, but just a quick. It's really again, data is number one. So, do I have the data? Is the data what I need for machine learning? Is the model will give me the right accuracy? Is it reliable enough for my business decision? Is I'm doing something compliance related or risk related or fraud related, or is it something very nice to have marketing campaigns and I'm sending a letter, maybe 10 cents a pop, sort of. I have to understand that level. Do I have to explain the model? Does it have a payoff? What the cost of doing the model? Some people say, this model will make us $1 million. Okay, I bet I need $2 million to actually deploy it. I mean, just numbers, but you have to understand what you're in for, the full picture. And that's the role of AI architect, okay, or full stack data scientist, is that it's not just doing something on a laptop and with nice graphs and good colors and say, oh, hallelujah, we finished. It's really taking it all the way to the bank. Get ROI. With this in mind, that's sort of good. Thank you for the timekeepers. So we reviewed the current machine learning landscape. It's very, very crowded. It scares you, but it really actually is much more navigable than you think. It's very, I think it's now with the development in technology, it makes it very easy, I think, for anyone. I was mentioning earlier, everyone, no excuse, everyone should learn data science, because thinking of data will improve your life in whatever professional life, even in personal life. You have to understand the limits of the data and how deep learning and reinforcement learning affects that. Okay, so there are limits. You have to be aware of it and use within the boundaries of these limits. For the business, always watch the new and the shiny, but use only proven technology. Okay, to get to in business, reliable technologies, and which is people understand and have applied successfully before. Focus on data and domain knowledge to understand your business, understand what machine learning can do and what problems should you use machine learning for or not. At the end, I really encourage anyone who has not have studied data science to study data science. Really very important for your skills. Like when people say, coding is a skill the same as reading and writing, will be in the future. I think data science is much, data literacy, I think it should be a must, it should be in schools. But if you are a practitioner, incorporate this new deep learning and reinforcement learning, because this is really the shape of things to come, and you have to incorporate it in your repertoire. But having did that, don't get infatuated with machine learning models and all these big fancy things. Focus in your data and the domain knowledge, because this is really what will give you the valuable business value in your day-to-day life. With this, I put it for questions.
So we'll have a minute or two for questions. Anybody want to ask the first question?
Was something called deep data. You heard about that?
Sorry?
Deep data?
Deep data.
Yeah.
There's a lot of many fancy words going on. Now well, actually, I'm supposed to answer all questions. No, but maybe somebody in the audience heard about deep data. It could be a product. It sounds like a vendor-made product. It's academic thing. No, I haven't not heard about that. Deep data, yeah, it's interesting. No?
All right, question from this side.
Hi, thank you for your presentation. Yeah, I'm currently a PhD working on the medical data. So usually the data I worked with are usually the size is very small. So I'm curious, in business usually I think the data size will be like very big. So does the machine learning really, or deep learning very effective on this data size? And I have a second question.
Yeah.
It's about the automated machine learning.
Yeah.
It's a very hot topic nowadays. So do you think in the future the automated machine learning will replace data science?
Okay.
Data scientists?
Yeah. Thank you for your questions. So working in the medical data, there's like health data will overtake all other data combined in the next year. So you're in a very good position. Unfortunately, the bad news is that deep learning, which is really the new most powerful tools we have, it requires a lot of data. That's the reality. But then if you explore these other techniques, some of them they can work very well with a small amount of data. So this is actually the advice using multi-algorithm. When you start, look at your data and apply this multiple algorithm and see which one will work. And it's obviously analysis, understanding the characteristics of the data may give you a hint which model is most useful. But deep learning is at this state of the art is really require a lot of data. There's no way around it. Okay, that's unfortunate. But as I said, apply these other techniques. On AutoML is a product by Google, but actually there's many similar products in the market, which is only what it does, it's fine-tune the architecture and the parameters of your model. So it doesn't really, it's still using the same deep learning models, okay? And in perception, speech, etc., it does that very well. In other areas, it's really like it's try and error almost, okay? So with these things, you should always try these things. Once usually give you free trial, so try it. But it's really will not help you without a lot of data.
Hi, I'm Greg Pearl from the ONSET group. I head up the data science and analytic area there. I hope you enjoyed tonight's presentation. Always fantastic information that we get from that. The ONSET group are the premium technical recruiters across obviously data science, machine learning, NLP, artificial intelligence. I'm here to help organisations build their analytics team and their analytics function with superior talent. There's lots of people out there, really good individuals across a range of different sectors that could be beneficial. And obviously I'm also here for the data science community to assist with understanding the market, understanding what jobs are out there, how to get into data science. So please feel free to reach out. So again, it's Greg Pearl at the ONSET group, and I look forward to seeing you at the next meetup.